video, I want to discuss the general overall process for accessing your database data in your .NET applications. And so during the course of this, I want to talk about the overall migration from the original .NET data access strategy, which was called ADO.NET, to a newer strategy that's come out more recently. So let me begin by saying that when I sat down to decide how to approach the topic, I had a decision to make. As it turns out, there are many different technologies and techniques that I could choose from to present to you, and that's due to the fact that it's a complicated topic, and there have been many different technologies and APIs that have been released by Microsoft in recent years for this very purpose. So I asked myself, should I demonstrate the data access technology that was popular years ago, since there was so much code written and is currently in the wild that uses that technology? Or should I look forward and only demonstrate the data access technology that more developers consider to be modern and that they're using today? You know, the technology that all the cool kids are currently using. And ultimately, I want to believe that I'm helping you either move ahead in your current job, or I'm helping you leapfrog over those who don't spend a lot of time upgrading their skills. So I'm going to assume that you are going to be writing new code, and therefore I'm going to eschew the older database access technology for the remainder of these videos after today. If, however, you find yourself maintaining code that was written a few years ago, which is quite honestly a common task for more junior programmers to tackle, then we have quite a few videos already recorded in previous years that cover the older technologies. Soon, if we haven't done so already, we'll be moving these to an archive area and ultimately, probably someday, removing them from the site completely. But at any rate, let's start out with just the basics. In many cases, you're going to write applications that will need to work with data. Customer records, order records, product records, vendor records, diagnostic data that's pulled from other computers or from actual machinery like robots, blogs, articles in content management system, and other content needs. They have to be saved and managed, and quite frankly, there's been an explosion of data in the last 20 years with the advent of the internet and with all the data entry that's gone on there. Database applications, whether it's presented as a local Windows application or as a web application, is one of the most common projects that developers have been tasked with building in recent years. Personally, I've written dozens of applications over the years that have collected data, retrieved data, allow users to edit the data, to insert or delete data. And so all those projects require that I store or access data in a database, and that's why I put so much emphasis on that topic up to this point. So I'll create either a Windows or a web application in .NET to allow users to interact with the data so that they don't have to learn the cryptic language of Transact SQL like you did in the last couple of days. And so there's a good reason or two why that you would want to kind of protect the database from the user and the user from the database. Let's go through a couple of them. First of all, in most cases, it would be way too expensive for every employee that needs the data to actually learn how to write Transact SQL. That's a really specialized skill that can be relegated to more technical types like you and me, okay? Secondly, it's not a good idea to give users raw access to the data. I mean, one accidental or even one malicious line of Transact SQL code could wipe out all the data in the database, and we certainly don't want that. So we want to create some protection around the data. Third, often the data by itself is not very meaningful. We typically want to enforce some business rules on the data before it's saved into the database. Or we want to give some context to the data and merge it together to give it the proper context as we're building reports. A business rule can mean many different things, but typically it means operations that have to be performed on the data before it can be saved into the database. And you could express these business rules in Transact SQL, but since we want the rules to apply regardless of of the user. For the sake of uniformity, we need to create a layer between the end user and the database. So we'll either write some C# code in the form of an application to do this, or we'll write stored procedures to enforce those business rules like we saw in the previous videos from today. The fourth reason why we might want to abstract the user away from the data and insert an application in between is because we may not want just anybody to be able to touch the data. Just because they work for the company doesn't mean they should be able to see or to modify all the data that's in the database. So we need to do some checking of the user's credentials before certain aspects of the data are made available to view or modify or delete. So in order for an application to access data that's in a database, there's a couple of fundamental steps, technical steps, that are required regardless of the database vendor. First of all, the application that you're writing, the .NET application, it needs to know where the database is located or how to connect to it. Whether it's in a file or on the network, whether opening a file up from the local hard drive or sending a message over the network to a computer that's hosting the database service that's waiting for such request as what we're currently sending. So the first step is the handshake, which is a computer term that refers to initialization. In some cases, that handshake is very simple. In other cases, the application or the user's credentials have to be passed to the database to determine whether it's even allowed to access that database. So that's step one, is the handshake or the initialization phase. Step two, after that initial connection and handshake, then the client application can issue a command. And by command, I mean something like select this data, or update that data, or delete this data, or insert this into that table. Or it could be a command to execute a stored procedure that we know exists in that particular database, like we looked at earlier today. So then the third step after the command is that if we're talking about a server-based database, like SQL Server Express Edition, if you recall from the previous video, then the database may have an extra layer of security that may want to check to make sure that this particular user is authorized to perform that action on the given database object. Perhaps some users are restricted from updating or deleting or inserting data, or they're restricted from using some stored procedure. Maybe those are only available to those with manager privileges or some sort of privilege within our application that our business deemed would be appropriate. So then after that check is made, it's optional depending on the type of database we're working with. Then whatever it is, the database engine or some assembly, .NET assembly or some unmanaged assembly, something is going to actually take action and look up the data based on the command that you passed to the database engine. It's either returned to the application or the data is modified in some way in the underlying file that stores the data. Now, while all these steps are generally used by all databases, the particulars between the vendors or even different products by the same vendor of how these steps are accomplished can be extremely different. And so ideally, all those vendors just hide, or rather they encapsulate all the low-level details that are required in order to access their particular database behind some interface, pulling back your experience from object-oriented programming, some interface that's generally the same regardless of that particular vendor or product. And fortunately that exists today, though it hasn't always been that way for developers. And we'll talk about that more in just a moment. Ever since I started developing applications using Microsoft technologies way back in the ancient dinosaur days of 1993 and Visual Basic 3.0, it seems like every 2 years there's a new data access strategy that's been released by Microsoft. Just about the time you get comfortable learning one of them, Microsoft says, hey, we were sitting around talking about it one day, and we realized that our current technology for data access had a couple of problems. So we wanted to redesign it completely from scratch give you something that would solve all those problems. And so then the whole process would repeat itself every couple of years. And maybe that has something to do with the turnover at Microsoft. I really don't know. Can't comment on that. And I was tempted to go all old man on you and recount the history of Microsoft data access technologies from 1993 forward, but for your sake, I decided to skip all of that. I'm sure Wikipedia or some blog or some book could help you out there. You want to see action, right? You want to see the code actually running and working, right? Okay, so let me do this. In an effort to give you a glimpse into the fundamental differences and styles between the data access technologies that are available, those from several years ago up to those that are available and usable right now, I'm going to show you 4 different approaches. But then we're going to settle on the final one, link to entities, for the remainder of this series. Don't worry if that keyword doesn't ring a bell for you just yet. Link to entities is actually part of a larger API within an API, okay? What I mean is we're going to look at ADO.NET 2.0, which was released, I believe, back in 2003. We're going to look at that in the next couple of videos because it's been popular for the last several years. Then a couple of years ago, Microsoft released ADO.NET 3.5, and with it came the entity framework, which was still part of ADO.NET. It's just part of a larger family of technologies, but it's kind of a subset of what was already available from ADO.NET. The older ADO.NET technologies, they still work, and they're a still valid way to develop your applications. It's just that Microsoft added the new entity framework to address some newer approaches in software development that have become popular since ADO.NET 2.0 was first introduced. And so that's what I meant by an API within an API. We're still talking about ADO.NET. It's just a newer section within that entire neighborhood. So we're going to start with ADO.NET and then move on to ADO.NET 3.5, linked to entities. And so here's the game plan over the next couple of videos. First of all, we're going to look at the first approach is we're going to use ADO.NET 2.0 code and using a data reader and what we would call a connected a paradigm with the database. Then on a second approach, in a second video, we're going to look at just using ADO.NET 2.0 code, but taking a more disconnected approach, using a data set. In approach number 3, we're going to then look at data binding and use no code whatsoever to wire up data from our database and display it on a form within an application. And then finally, we're going to move on to link to entities to kind of show that progression of thought and how it's changed. And then we're going to focus primarily from that point on link to entities. And I realize this is going to be a whirlwind tour at first. I just wanted to help you appreciate as we go through this process at a high level the differences between the data access strategies and how Link is so dramatically different from what developers were used to up to that point. So on days 9 and 10, we're going to be exclusively studying link to entities, and the entity framework. Okay, so let's pick it up in the next video. We're going to start our approach of working with the older ADO.NET 2.0 technologies and work our way forward. So we'll see you in the next video. Thank you.